Hi, in this video we're going to look at web methodologies, so specifically the process that we're going to use in order to develop websites. Now what you will find is actually that these methodologies are not actually specifically designed for web, they're designed for software development in general. There may be kind of one or two ideas out there that you would do, or maybe one or two ways that you would tweak it specifically for web, but in general the methodologies and models that we use to develop stuff are kind of interchanged across all kinds of different types of software, because ultimately they're all different types of projects. So the first thing we're going to look at is Waterfall model, probably the most famous one, and it's basically the logical steps in order to develop websites in this example, but so you can interchange it into things such as developing a software application or a database or whatever it might be. It's a pretty linear flow, and you would ideally get it signed off at each stage. So each stage is a specific set of deliverables, and once you've gone through that stage and you've delivered your deliverables, then you continue on to the next one. So it says that, going back is not possible. I mean, ultimately, if you are testing, you might have a little bit of leeway there, because if you find something isn't working, you may well have to go back. But it's not ideal in this model. Some advantages for the Waterfall model: so it's very simple to use and understand. It's very kind of logical in terms of one step follows another. It's easy to manage because ultimately each step has very specific goals, and you look to complete those goals before you move on to the next step. And it works well for projects which are reasonably smaller. So if you want a bigger project, you might want to be a little bit more kind of flexible, because you might have multiple different goals and so on. Disadvantages: so once a phase is complete, it is difficult to go back. So especially in the testing stage, this is where if you find errors with the code, it's actually going to be quite a big issue, really. You're not going to have any working software until the end, which is not great, because ultimately you want to see this thing in action, and if you need to make any changes to it, you might want to be able to do that. High amounts of risk, because you don't have that working software till the end. So therefore you don't know exactly what's going to happen, and you can't necessarily change it. What has been set in motion is what has been set in motion. And those last 2 points kind of intertwine, really, so it's not good for longer and more complex projects, which may require more flexibility, more ability to go back and change stuff if people aren't happy with it, and so on. The second methodology we're going to talk about is Agile development, and what we're looking at here is the ability to be. Well, see, the word is in the key word is in the title. We've got Agile there. The idea is that when you're doing this project, you have the ability to change, and along every step of the way. You still do have similar steps like you would do in every one of these models, but the idea is that after each step it is reviewed, evaluated by the team and the customer, and then if we need to go back and make any changes, we can do that. And it relies on a high level of customer involvement, which is good on one hand, because it's always quite nice, or at least I think quite nice, to get the customer involved. It gives them more kind of ownership over the finished product, but there are also kind of disadvantages with that, whereby, let's say for example, if a customer changes their mind, which is a more common occurrence than you would think, it can result in carnage, really. So advantages: like stakeholder is anybody that is involved with the or has an investment with the. When I say investment, I mean maybe it could be time, could be money, could be they've worked on it in the project. You've got transparency, so people can see what's going on. Allows some modification. People can change what's going on. People can go back and change stuff. You can change deliverables potentially going forward. Whatever it might need. You can predict as much as you ever can predict the cost and length of a project. we've seen multiple different instances of projects going over budget and longer, but ultimately those ones that actually get done shorter don't actually tend to get a lot of press time, which is quite interesting. But anyway, and the focus obviously on the end user. So the end user is the people that are going to be using the system that you are creating. Ultimately, the most important people in the project are the end users and the people that will use the project, in this instance the website, at the end of it. Disadvantages for this: so it can be difficult to predict the larger projects, as with anything really. Things can go astray, especially if the customer has input on it and then decides that actually they want something different to what was originally planned. That can definitely make it more difficult to predict in terms of length and cost, and also things like specialist skill sets. There is less emphasis on things like the design of the project. That could make it more interesting as well, because actually design is quite important, especially if you think about something to do with a website. Designs are critical in the way it looks and the way it works. Within the Agile model, only senior programmers or developers are capable of making decisions. Generally, when you're talking about project, the guys that are higher up the stream, so the senior programmers, developers, etc., will be the ones that ultimately make the decisions. But in this instance, especially so, and therefore it's not good for newer programmers who would have kind of less of a say. That may be good in some instances, if you get some people that kind of need to learn the ropes, but also in terms of developing people, it's not so wonderful. Spiral methodology is a risk-driven software model. Now, ultimately, there is more risk analysis in this model than the other models, and it can be seen as a combination of in this, more than one different type of model. So in this sense, you've got Waterfall and Iterative. There are going to be similar different ideas to what are in previous models. So you've got different steps that you need to be taken. You've got different things that need to be done. But in the critical difference between the Spiral and the others, in my opinion, is the amount of risk analysis, and therefore it will allow less risk within the project, or that is the idea behind it anyway. And therefore it should be better for larger and mission critical. So we talk about mission critical. It's not in your computer game, if you have a mission, you have to do a certain thing. So you might have to I don't know, acquire a certain amount of product, whatever that might be. But in this instance, the mission, it would be to undertake a certain action. So it might be to design the front page of a website or attach it to your website, whatever it might be. You can add additional functionality. This is critical, really, because within software development of any kind, additional functionality has always been brought out, and especially so with things like web, where you've got the HTML5 language, which is still kind of bedding down. There's going to be more functionality brought out for that. Your website's going to be they're going to need to be more kind of flexible, because you're going to need to potentially change it in not very long. Ultimately the sites are always being developed and maintained and so on. You get software early, which is good, so you can get to have a look at it and you can get to see what's going on. You can get to modify it if you so wish. Disadvantages: can be costly, there's more risk analysis. You can see it's quite a lengthy process, but because there's more kind of risk analysis and more steps along the way, actually it is going to cost more. The risk analysis itself can be dependent on if you have specific expertise in that area. So it's more difficult for somebody that hasn't got expertise in the area to really kind of analyze the risks in it, because how would they know, or how would they know as effectively as somebody that does have quite a lot of expertise in a certain area? So if you're a web developer and you've been working on something for a long time, and working within web development for a long time, you're going to be able to spot risks. So let's say, for example, holes within your security that might mean that somebody can hack into your database easier, as compared with someone that has only just started doing it. It could be harder for them to spot. But all of that would mean that, ultimately for smaller projects it is not as useful, because ultimately it's really designed for bigger scope, and therefore for smaller scope ones it's not going to be as effective. We've got Iterative, so this focuses on simplification, and ultimately you're looking at constantly kind of having simple version, and you're reviewing it and you're building it up slowly and surely, and then you get to a point whereby you have your finished product. It's a bit more complex than that, obviously, but ultimately you're constantly reviewing, you're constantly looking at the requirements of a system, and you're adding to it and building it up. So this it can be useful, because obviously you get your software early, and it can be useful because you can find flaws and change them earlier. But actually, in terms of amount of risk, well, this is going to be one of the highest ones, because you don't actually know what you're going to get to the end, really. You're going to need to really kind of be very clear about where you want to go, and kind of stick to it. It can be quite difficult to do that, and you may find that you need to require contractors to fulfill specific skill sets, such as if you don't currently own someone who is a developer in a certain language, let's say PHP. Just as a random thing, if you haven't got somebody who is an expert in that, you may need to hire them. Advantages, so implemented during early stages, so you get some software earlier. It can be easily adaptable, because you're constantly reflecting, you're constantly changing all the time, and therefore it makes it easier for you to make changes, because you're going to be able to make them earlier. It is best suited for those organizations that are set up as agile organizations, so they're more kind of flexible, and you can see there are kind of a number of different things that can be traced across. It's the best word that I can think of right now, and therefore it will be quite a good thing. But ultimately, you do have to be a little bit careful with it, because of the way that this is built. Disadvantages, so each phase can be rigid with no overlaps. That's always going to be an issue, I guess, in terms of once you reach a certain point, then you move on to the next phase, and then you concentrate just solely on that phase, and you make sure you kind of get it right. It can be difficult, but ultimately, it could be very interesting as to how somebody actually goes about implementing, the iterative model, because you can either do it more waterfall type based, which is where I think each phase can be less rigid will come from, or you can do it more agile based, and either one of those will have risk, because with the waterfall one, so you've got very rigid stages, whereas with the agile and iterative ones, you are constantly evaluating, constantly potentially making modifications, which can lengthen the time and cost of your project. Now, obviously, because of that, it's generally not as suitable for smaller projects, because it may need to differentiate. It may need more money given to it, and therefore, it could be not quite as suitable for them as other things. Well, thank you very much for watching. Hopefully that has helped you, and I look forward to seeing you soon. Goodbye.